Hello everyone. Today we're diving into the fascinating story of two captivating celestial neighbors, the Leo or dwarf galaxy and the bright star Regulus. Imagine this, a tiny galaxy hidden in the depths of the universe, right next to one of the brightest stars in the sky. The story of these two celestial bodies is nothing short of a galactic dance. First, let's take a closer look at Leo the Fern. This dwarf galaxy is one of the farthest satellite galaxies of the Milky Way, located about 820,000 light-years away. With its very low surface brightness, it's always been a challenge for astronomers to observe. But this is where the Hubble Space Telescope comes in, revealing the secrets of this tiny galaxy. Right next to Leo Y is the bright star Regulus. Known as the Little King, Regulus sits at the heart of the Leo constellation, about 79 light-years away. This star has been historically significant, revered by ancient civilizations from Persia to Rome as the royal star of the sky. So, what does it mean for these two celestial bodies to be so close to each other? This is where the story gets interesting. The brightness of Regulus makes observing Leo the Reader quite challenging. But despite these challenges, the capabilities of the Hubble telescope allow us to uncover the mysteries of Leo the Urn. In today's video, we'll explore the relationship between these two celestial bodies, the observations made by the Hubble telescope, and the contributions of these observations to the field of astrophysics. If you're ready, let's dive into the secrets of this galactic dance. Leo Urn is like a hidden gem in the depths of the universe. Known as one of the farthest satellite galaxies of the Milky Way, Leo the One is located about 820,000 light-years away. Due to its very low surface brightness, observing it has always been quite a challenge. But what makes Leo I so special and interesting? The discovery of Leo I actually happened relatively recently. It was first noticed in photographic plates in the 1950s, but visual observation wasn't possible until the 1990s. The main reason for this is the low surface brightness of Leo the Fern and the bright light emitted by its neighboring star, Regulus. However, with the advancement of technology and the high-resolution images provided by the Hubble Space Telescope, astronomers have started to reveal the secrets of Leo the Fern. Let's look at some of the interesting features of this tiny galaxy. Leo the Fern has very low metallicity, meaning the stars and other materials in the galaxy lack many of the heavy elements found in our Sun and other larger galaxies. This provides important clues about the evolution of Leo the Fern. The sudden stop in star formation about 1 billion years ago is likely linked to interactions with the Milky Way and environmental effects within the galaxy. Hubble's observations have allowed us to better understand the internal structure and dynamics of Leo the Fern. For example, Hubble has found hints that there might be a massive black hole at the center of this galaxy. This discovery is quite surprising for a small dwarf galaxy, as massive black holes are usually found in larger galaxies. Leo Y continues to fascinate us with its cosmic mysteries. Now, let's take a closer look at its bright neighbor, Regulus, and discover its story. Regulus shines like a royal crown in the sky. Known as the Little King, this bright star sits at the heart of the Leo constellation. But what makes Regulus so special? Regulus is a blue-white main-sequence star located about 79 light-years away. With a surface temperature of about 12,000 Kelvin, it is approximately 160 times more luminous than our Sun. Due to its brightness and position, it has been regarded as the kingly star by ancient civilizations. The ancient Persians considered it one of the 4 royal stars of the sky. Regulus is notable not just for its brightness, but also for its rapid rotation. The star completes a rotation on its axis in just 16 hours, compared to the Sun's rotation period of about 27 days. This rapid rotation causes a noticeable bulge at Regulus's equator, giving it a slightly elliptical shape. Regulus is also part of a binary star system. In fact, the main star, known as Regulus A, has a white dwarf companion. This white dwarf hasn't been directly observed, but its presence has been inferred from the small changes in Regulus A's movements. The astrophysical significance of Regulus is also considerable. Observations suggest that there could be planetary systems around this star. Moreover, because Regulus is very close to the ecliptic plane, it is frequently occulted by the sun and the moon, providing astronomers with opportunities to study the star and its surroundings in detail. Regulus has a rich history and a prominent place in the field of astronomy. The Greeks called this star Basiliskos, meaning little king, while the Romans named it Basilica Stella. Nicolaus Copernicus translated these names into Latin as Regulus. Now, let's explore the relationship between this royal star and the nearby Leawarr dwarf galaxy, and how the Hubble Space Telescope has contributed to our understanding of this dynamic duo. Leo Y and Regulus are positioned very close to each other in the sky. However, this proximity makes it quite challenging for astronomers to observe Leo the First's. Regulus's brightness combined with Leo the First's low surface brightness creates a significant observational challenge. Regulus, as one of the brightest stars in the sky, is easily visible to the naked eye and through telescopes. This bright light often overshadows the faint glow of Leo the Marn, making detailed observations difficult. However, astronomers have developed various techniques to overcome these challenges. For instance, the Hubble Space Telescope, with its high-resolution imaging capabilities, has been able to observe Leo Fur in greater detail. How does Hubble perform these observations? Positioned outside the Earth's atmosphere, Hubble is free from optical pollution and atmospheric distortions that affect ground-based telescopes. This advantage is crucial when observing faint objects near bright stars. Hubble's wide-field cameras and high-resolution spectrographs enable detailed study of Leawarr's structure and dynamics. Despite the brightness of Regulus, Hubble's capabilities allow us to gather significant data about Leo there. These observations provide insights into the galaxy's internal dynamics and how the bright light of Regulus affects it. This relationship between Leo Ban and Regulus reveals important details about galactic interactions and dynamics. Additionally, Hubble's observations have helped us better understand the internal structure of Leo the Farn. These include the potential presence of a massive black hole, star formation rates, and the galaxy's evolutionary processes. Hubble's detailed observations highlight the importance of the proximity of Leo Fur and Regulus for galactic research. Now, let's look at the scientific contributions of Hubble's observations on Leo Fur and Regulus. Now let's delve into the observations made by the Hubble Space Telescope on Leo Fur and Regulus and the contributions these observations have made to the scientific world. Hubble has been a revolutionary tool for space research. Located outside the Earth's atmosphere, Hubble provides clear and detailed images of the universe's depths without the optical pollution and atmospheric distortions faced by ground-based telescopes. This is particularly advantageous when observing faint objects near bright stars like Regulus. Hubble uses wide-field cameras and high-resolution spectrographs to observe Leo the Fur. These instruments allow us to examine the structure and dynamics of Leawarr in detail. For example, Hubble has found hints of a potential massive black hole at the center of Leawarr. This discovery is surprising for a small dwarf galaxy, as massive black holes are typically found in larger galaxies. The data provided by Hubble offer significant insights into Leawarr's star formation rates and the environmental effects on the galaxy. Leawarr's star formation suddenly stopped about 1 billion years ago, likely due to interactions with the Milky Way and loss of gas. Hubble's observations reveal the low metallicity of Leo the Rhyn and the composition of its stars, providing clues about the galaxy's evolutionary history. Hubble also helps us understand the dark matter distribution and the internal structure of Leawarr. By measuring the radial velocities of bright red giant stars in Leawarr, we gain information about the galaxy's mass and dark matter content. This data offers crucial insights into the galaxy's internal dynamics and dark matter distribution. Hubble's detailed observations emphasize the importance of the proximity between Leo Fur and Regulus for galactic research. The data from Hubble has significantly contributed to our understanding of galactic evolution, black hole formation, and dark matter distribution. Exploring the secrets of Leo the Rhyn not only provides insights into this small galaxy, but also helps us understand the formation and evolution processes of galaxies in general. Hubble's observations contribute to our understanding of the role of small galaxies within larger galactic structures. Now, let's look ahead to future research and discovery potentials involving Leo Pharon and Regulus. The secrets of Leo Pharon and Regulus that we've uncovered so far are fascinating. However, the discoveries don't end here for the scientific community. There are still many unknowns surrounding these two celestial bodies, and future research aims to uncover these mysteries. With the data provided by the Hubble Space Telescope, research on Leo Pharon and Regulus continues. New observations are planned to gather more information about Leo Pharon's galactic structure and dynamics. Specifically, further studies on the potential massive black hole at the center of Leo Pharon and its role in the galaxy's evolution are needed. Ongoing studies with the data provided by the Hubble Space Telescope, research on Leo Pharon and Regulus continues. New observations are planned to gather more information about Leo Pharon's galactic structure and dynamics. Specifically, further studies on the potential massive black hole at the center of Leo Pharon and its role in the galaxy's evolution are needed. These studies will help us understand black hole formation and development in smaller galaxies. The James Webb Space Telescope, JWST, is set to take over Hubble's legacy, offering deeper insights into the universe. JWST's higher resolution and broader spectral range will allow for more detailed studies of celestial bodies like Leo Pharon and Regulus. JWST's infrared observations will provide clearer images of Leo Pharon despite its low surface brightness, helping us understand the galaxy's structure and dynamics better. Additionally, large ground-based telescopes, such as GMT and ELT, and other space-based observatories, will contribute to the research on Leo Pharon and Regulus. These telescopes will scan broader areas and conduct more detailed spectroscopic analyses, providing more information about the galaxy's chemical composition, star formation history, and dark matter distribution. Future research will deepen our understanding of the evolutionary history and interactions between Leo Pharon and Regulus. These studies will shed light on how galaxies form and evolve, highlighting the role of small galaxies within larger galactic structures and their environmental impacts. Understanding the secrets of Leo Pharon helps us grasp broader galactic formation and evolution processes. Hubble's observations and future technological advancements will continue to reveal the mysteries of these celestial neighbors, enhancing our knowledge of the universe. If you enjoyed this video, please subscribe to our channel, like this video, and turn on notifications to stay updated with our latest content. Share your thoughts and questions in the comments below. Let's continue exploring these fascinating galactic stories together.